If a rogue planet were coming for Earth, the first thing that kills your survival plan probably isn't the impact. It's the ocean quietly deciding the beach belongs somewhere else. Because when people imagine this, they usually picture one clean moment. A giant dark planet fills the sky, everything flashes white, and that's it. Simple. Terrible. Done. But a planet collision isn't just a bigger asteroid strike. It's more like another world walking into the room and every rule in the room changing before it even touches anything. That's the part that makes this question nastier than it sounds. You're not only asking, could I survive a crash? You're asking, could a human body, a city, a bunker, an atmosphere, and the crust of Earth survive being put inside a gravity machine the size of a planet? And the annoying answer is, it depends. A tiny rogue world passing nearby is one kind of disaster. A moon-sized body clipping Earth is another. A Mars-sized planet hitting us is the kind of event where the word survive starts doing a lot of emotional labor. So imagine the story starts quietly. No fireball, no dramatic sky monster yet. Just astronomers finding a faint moving dot that shouldn't be moving that way. It isn't a comet because comets are mostly ice and dust. It isn't a normal asteroid because its pull on other objects says it has serious mass. It's a rogue planet, a world that got kicked out of its star system or formed alone and now drifts through space without a sun to call home. Space is huge, so this is wildly unlikely. But unlikely isn't the same as impossible, and physics doesn't care whether the plot feels fair. If the path crosses Earth's path, the first countdown isn't to impact. It's to when its gravity starts messing with us. Gravity feels gentle because we live with it every second. But up close, a planet's gravity isn't gentle. It pulls harder on the side of Earth facing it than on the far side. That difference is called tidal force, which is just a clean way of saying one side of our planet gets yanked more than the other. The moon does this all the time. That's why oceans rise and fall. But replace the moon with something much heavier, closer, or both, and the ocean doesn't politely make tides anymore. It sloshes. Entire coastlines become temporary suggestions. Water can surge inland, drain weirdly, then come roaring back from angles nobody built for. And it's not only water, the atmosphere gets stretched too. Pressure systems go strange, winds get ugly, the crust flexes, fault lines that were already stressed get shoved. Earthquakes become more likely before anything hits. So if you're standing in a city waiting for the collision day, the disaster has already started. The sky might still look normal, but ports are drowning, satellites are drifting, GPS is lying, and every scientist who understands orbital mechanics has the same expression. This isn't an impact problem yet, it's a planet problem. Now here's the first big split. If the rogue planet only passes near Earth, survival is possible in the same way surviving a historic super disaster is possible. Awful, uneven, unfair, but possible. If it passes close enough to twist our oceans and crust but misses the planet, the damage could still be civilization breaking. Food systems fail. Coastal cities are erased. Weather goes feral for a while. The moon's orbit might change. Earth's day could shift slightly. But somewhere, inland, prepared, lucky people could make it through. That version is horrible, but it still leaves a world afterward. A damaged Earth. A traumatized Earth. But Earth. The collision version is where the bunker fantasy starts falling apart. Let's say the rogue body is small by planet standards, maybe around the size of the moon. That's already enormous. The asteroid that helped end the dinosaurs was tiny compared with that. It was mountain scale. A moon-sized impactor is world scale. When something that big hits, the energy doesn't stay local. It travels through the planet as shock waves. The ground doesn't just shake, it rings. Rock behaves less like solid floor and more like something that can splash, crack, melt, and flow under insane pressure. A normal explosion pushes air outward. A planet impact pushes reality outward. The impact site becomes a temporary ocean of molten rock. Ejecta, which is just blasted material, gets thrown high above the atmosphere and rains back down around the globe. When all that hot debris re-enters, it heats the sky. Not metaphorically. The sky can become an oven. So if you're thinking, okay, I'll go underground, that's better than standing outside, obviously. But underground doesn't mean outside physics. The shock travels through bedrock. Heat moves, air systems fail, water systems fail, entrances collapse. And if the surface above you is being cooked, shaken, buried and stripped, a bunker becomes less like a shelter and more like a sealed container with a timer nobody can read. Hold on though, because the worst version isn't even the explosion. It's what happens to the whole planet afterward. Earth survives normal asteroid impacts because Earth is much larger than the impactor. It absorbs the hit, gets scarred, and keeps being Earth. But when the incoming object is planet-sized, the impact can change Earth's rotation, tilt, orbit, and internal structure. It can melt huge portions of the mantle. It can blast parts of the crust into space. It can turn the surface into a magma ocean. That phrase sounds dramatic, but it's basically what it says. A global or near-global sea of molten rock. No forests, no oceans as liquid water on the surface, no breathable air in the familiar sense, just heat, vapor, falling debris, and a planet trying to become solid again. This isn't science fiction nonsense either. The leading idea for how our moon formed is that early Earth was hit by a Mars-sized body, often called Theia. That collision threw material into orbit, and some of it gathered into the moon. Early Earth didn't shrug that off. It was remade. And that's the uncomfortable middle answer. If a Mars-sized rogue planet hits Earth, the question isn't, where should you hide? The question is, what counts as Earth afterward? Because from far away, there may still be a planet here. Gravity may pull the debris back together. The leftover world may cool over time. But from a human survival point of view, that's not a bad day. That's the end of the operating system. Could anyone survive in space? That's the loophole people reach for, and it's worth taking seriously for a second. If humans had a self-sufficient colony far from Earth, with its own food, water recycling, power, shielding, medical systems, and enough spare parts to last for generations, then yes, humans could survive Earth getting hit. But that's really saying humans could survive somewhere else. A space station in low Earth orbit probably wouldn't be a magic escape pod. Earth's gravity field would be changing during the encounter. Debris could fill nearby space. The atmosphere might expand or get blasted outward. Orbits would become unstable in ways that are hard to overstate. Anything close to Earth is still inside the disaster. A moon base might not be safe either because the moon's orbit could be disturbed, and if the impact sprays debris outward, the moon becomes a target. Mars, deep space habitats, or ships already far away are better bets. But again, that's not you surviving the collision from Earth. That's you having left the story before the final chapter. So what about the classic question? What if you were on the opposite side of Earth from the impact? That feels like it should matter. And for a smaller asteroid, it absolutely does. Distance helps. The planet blocks the first blast. Local geography matters. For a planet-scale impact, opposite side is more like being on the other side of a bell when someone hits it with a wrecking ball. The shock doesn't stop at the horizon. It moves through the whole body. Waves of rock and pressure converge. The surface can heave, crack, and rupture far from the original hit. The atmosphere doesn't respect your hemisphere. The heat and debris go global. There isn't a neat safe side. There's just the side that dies first and the side that understands what's happening a little later. But there is one version where survival gets weirdly interesting. A grazing collision. Not a direct center punch, but a glancing blow. Two worlds scrape past each other, trading material and momentum. This could still be catastrophic beyond anything in human history, but it opens a tiny crack in the answer. If the rogue body is smaller, if the angle is shallow, if Earth keeps most of its atmosphere and oceans, if the crust doesn't melt globally, if the orbit remains stable enough, then pockets of life might survive. Microbes are incredibly tough. Some deep underground organisms live without sunlight, feeding off chemistry and rock. Life has survived mass extinctions before. Humans, though, are needy. We need breathable air, drinkable water, stable temperatures, food chains, infrastructure, and time. A bacterium can wait in a crack in the rock. You can't eat vibes in a collapsed bunker for a century. That's the deeper survival split. Life surviving and you surviving aren't the same question. Earth has life forms that can endure boiling heat, freezing cold, crushing pressure, acid, radiation, and darkness. Humans are impressive because we make tools, not because our bodies are durable. Our survival strategy is civilization. And a planet collision attacks civilization from every direction at once. It breaks supply chains by breaking the surface they're built on. It breaks agriculture by changing sunlight, temperature, and soil. It breaks medicine by breaking factories. It breaks shelter by breaking climate. It breaks plans by making the next hour physically different from the last one. And then comes the quietest problem: time. Even if you somehow lived through the first impact, Earth afterward may take thousands or millions of years to become friendly again, depending on the scale of the collision. Oceans may boil away or later rain back down. The atmosphere may become toxic. The surface may cool into new crust. The planet may slowly settle into a new shape, a new spin, maybe even a new moon situation. For geology, that's recovery. For humans, that's forever. So the honest answer is layered. Near miss from a rogue planet? Some people might survive, though the world could be wrecked in ways we've never managed. Small planetary impact or moon-sized collision? Human survival on Earth becomes extremely unlikely, and civilization is almost certainly gone. Mars-sized direct collision? No, not from Earth. The planet may continue, matter may recombine, life might someday start over or persist in some hidden form, but you and everyone you know aren't writing that out. And weirdly, that's what makes the scenario so powerful. It shows that Earth isn't just a stage we stand on, it's the machine keeping us alive. Gravity, oceans, air, crust, orbit, rotation, sunlight, all of it has to stay within a narrow range for a Tuesday to feel boring. A rogue planet collision doesn't kill by being one big explosion. It kills by turning all the background settings into active threats. The floor becomes a wave, the ocean becomes a hammer, the sky becomes heat. The calendar stops mattering because the planet has entered a new chapter written in molten rock. So could you survive if Earth collided with a rogue planet? If it's a true planet-on-planet collision, probably not. The better question is almost stranger. Could Earth survive you? Could the world keep enough of itself to someday become recognizable again? And the answer there is maybe. Earth has been remade before. The moon above us may be the scar from one of those ancient collisions. Every night, it's basically a pale reminder that our planet's calm face has a violent history. So if someone tells you space is empty, they're mostly right. Thankfully. But it's not harmless. It's a dark room full of moving worlds, and life on Earth exists because for a very long time, none of the really big ones have walked through our door.